Today we are going to discuss a very interesting topic, that is aldehyde, ketones and carboxylic acid. We can broadly categorize all these three functionalities into one single category, that is carbonyl compounds. Now what are carbonyl compounds? Are compounds consisting of carbon oxygen double bond. Now we will try to understand the difference between all these three functionalities by writing the general formula. So let's write. So here I have got RC double bond O. Now you can see this is common in all three functionalities. Now if I attach a hydrogen to this carbonyl carbon, it will become an aldehyde. If I attach an R group, it will become a ketone. If I attach a OH, it will become the carboxylic acid. So this is how we write the general formula for all these three carbonyl compounds, that is aldehyde, ketones and carboxylic acids. Now we will move towards the methods of preparation. So in methods of preparation, let's start with the aldehyde. In case of aldehyde, we can prepare them from the primary alcohols, for example CH3, CH2OH. If we treat them with PCC, that is pyridinium chlorochromate, it will eat the corresponding aldehydes, CH3 C double bond OH. Now here I use the mild oxidizing agent. Why? Because this will stop reaction at aldehyde stage. If I use a strong oxidizing agent, it won't stop at aldehyde stage, rather it will move towards the carboxylic acid stage. Apart from that, we can also prepare aldehydes from acyl chlorides, like CH3 C double bond O Cl. So we will have to treat this molecule with Lindless catalyst, that is H2PD BSO2, and we will have to heat this reaction at 300 degrees Celsius, and it will yield corresponding aldehyde CH3 C double bond O H. So you see, this entire reaction is called as Rosenmund reduction. So these are the two methods of preparation for aldehyde. Now we will move towards the methods of preparation for ketones. So in ketones, let's start with the secondary alcohol. So we have got here CH3COH H CH3. If I treat this secondary alcohol with some oxidizing agent like KMnO4, it will yield corresponding ketone, that is CH3 C double bond O CH3. Apart from this reaction, we can also prepare ketones from Friedel-Crafts acylation. That is, here I will have to treat this benzene ring with acyl chloride CH3 C double bond O Cl in presence of anhydrous AlCl3. So you see, this will yield the corresponding ketone. So you see, this is acetone, this is acetophenone. Now we will move towards the methods of preparation for carboxylic acid. Carboxylic acid, we can prepare them from both primary alcohol and secondary alcohol. We will study from primary alcohol CH3 CH2OH. If I treat this primary alcohol with some strong oxidizing agent like K2CR2O7, it will yield corresponding aldehyde, that is CH3 C double bond O OH. Apart from this, we can also prepare carboxylic acid from hydrolysis of several molecules like anhydride, from nitriles, from acyl chlorides. CH3 C double bond O Cl, this is acid chloride, which upon acid hydrolysis like H3O plus will yield corresponding carboxylic acid CH3 C double bond O OH. So these are the methods of preparation for the carboxylic acid. Now we will move towards some reactions of these carbonyl compounds. So here we are going to study the aldol condensation reaction. In aldol condensation reaction, we need to have two carbonyl compounds, and at least in one of them we need to have a alpha hydrogen. There can be two types, one is self aldol, another one is the cross aldol. For timing we will study only self aldol condensation reaction. So for example, I have got here a molecule that is CH3 C double bond O H plus H CH2 C double bond O H. Here we have to treat this reaction with dilute NaOH. So you see, what will happen is this NaOH, it will abstract the proton of this carbon. This is the alpha carbon. So this is the alpha hydrogen. It will form a carbanion on this carbon. So let's see how it will form. It will form a carbanion like this, and this carbanion will attach this carbonyl carbon and lead to the formation of corresponding beta hydroxy carbonyl compound. So that is CH3, COH, H, CH2, C double bond O, H. So this is alpha carbon and this is beta carbon. So this is beta hydroxy carbonyl compound. Upon further heating, we will get corresponding alpha beta unsaturated compound. How? Because you see this alpha carbon, this alpha carbon will lose one of its hydrogen and it will lead to the elimination of water molecule and it will lead to the formation of corresponding alpha beta unsaturated carbonyl compounds. So CH3, CH, double bond, CH, C double bond O, H. So you see this is alpha carbon, this is beta carbon. So this is alpha beta unsaturated carbonyl compound and this molecule's name is proton aldehyde. So you see that's it for this session. Thank you for listening to me so patiently. Thank you so much.